Hi, I'm Matt with Schematical, and sorry we're late if you were expecting us to be perfectly on time. Uh, we've been very punctual, but
We
today
have,
just
but
wasn't happening. So Dom's
well,
travels changed the schedule up a little bit.
I don't think I've seen anybody log on at exactly the moment we've started before. So I don't think anybody's offended by this.
Let us know in the comments.
Please do. Please do.
All right. So today I've got good news. This is going to be a little more technical. Not that they're not all technical, but ElastiCache and ValKey have some pretty cool stuff they're
Mhm.
baking up. So if you're not familiar with ValKey, ValKey is a fork of Redis, which is a very popular data store,
Mhm.
or value key store to be specific, which is going to be important in a minute here. But basically, it's unlike a relational database. Typically, you say, I want key number 123 to store this information. So the only way you could access that is like, before, like if you wanted to search a user, you could search it by name, you could search them by
Mm.
email, you could search them by, something else. That's something you can do in a relational database. This technology couldn't really do that before, or at least it wasn't optimized for it in any capacity. But partially because they want to keep in the AI race, they have basically migrated to become some type of document DB, if you're familiar with that.
Mhm. Mhm.
MongoDB would be a good example where the fields, multiple fields in of an object could be indexed, which is fascinating that they're. I mean, it's part of me is like if
Mhm.
it's becoming more generic, which I generally
Well,
don't like. Go ahead.
is it generic or more functional? But I think where you're going at is irregardless, there probably has to be a performance hit somewhere.
Well, this is where it gets really interesting. They think they can shard slash partition to different hardware without taking a hit, at least according to the documentation,
Mhm.
which is very interesting. Generally, yeah, you could physically partition the records and have the record separate,
Mhm.
but then to have the device or the sorry, to have the index that knows, okay, all the users whose name starts with J is on this machine or whatever it
Mhm.
is, that would have to live on multiple infrastructure boxes, basically. So multiple pieces of
Or
hardware. This
Or do you think there's something magic they're doing with the various, maybe there's more than one key store at this point, perhaps?
possibly. Well, here's a theory I've got, and again, I haven't dug into it like down to the metal, but is that if you hit the wrong box would tell you, hey, this index actually lives on this other box, so it sends you over
Mm,
there, and maybe somehow the proxy aggregates the ones from the other boxes, or says, okay, you have to do two more calls out, like, and the client just picks it up,
mm.
the SDK, and so it's going to be interesting.
Well,
It's
do
been
you think there's going to be a performance hit? I mean, looking up a key, okay, give me user 123. Do you think that's going to be an order of magnitude faster than give me any user with the email address that starts with XYZ?
I would think the first one that you said would be in much faster than the second one,
Mhm.
yes. But they're saying it's still pretty darn fast. So um I don't know. I cannot wait to give it a shot. Like, so I love ValKey, ElastiCache, Redis as a tool. So don't get me
Mm.
wrong. I know I was picking on a little bit saying it's making it more generic, but in reality, I think it's doing it in a way that's more geared for the AI rush right now, because this really puts it in a contender for vector DB type stuff as well. So
Mm.
vector indexing, which
Yeah.
is this technology that I'm very interested in compared to
Do you,
LLMs.
do you think that any of this functionality is being ported back into Redis, or do you think this is a layer sitting on top of it?
So I've actually already done some work on this, and the Redis client has a bunch of the vector index type stuff in it.
Mm.
So if the Redis client does, I'm assuming Redis does, and I have read other ones. Actually, I did a post a while ago. I know Redis does. So they're doing a big push for AI right now too. So ValKey's just adapting what they're doing, but it's Redis Enterprise is closed source, so they're not stealing it directly from Redis. So they got some real smart people figuring this out on
Oh,
Valkey's
so
side.
So Redis is an open source, closed source model, much like MySQL, at least was. I don't know if it still is.
It was all open source. Then Enterprise went closed source, and I think they're, as far as I know, they're kind of abandoning Redis open source. It's like less maintained now. But then
Is it still freeware?
Redis open source is, but again, it's just likely out of date for the most part. You know, you're not getting up to date things. I haven't played with it in a while because ValKey is available for a third the cost at on AWS.
Fair.
So,
I mean,
yeah,
back in the day, I used a lot of Memcache, which
Memcache,
is
yeah, similar.
Back in the day, they were essentially the same thing. They were key value stores.
Right. Yep. And they're very good at what they do, and they're very easy to partition because you only ever looked something up by one key until now. So another thing they added was aggregations, meaning, you know, you wouldn't want to run this all the time, but you could run queries that basically span a whole bunch of records and then correlate those. So you could say, give me the highest from this, or give me the average or the P90 of all these values that are inside all these different key spaces, which is interesting. You know, I don't think that's going to be all that performant. Like if it's anything like MongoDB aggregations, it can get slow quick. So, but it's not a whole lot different than similar stuff I'm running on MySQL or Athena.
Well, and I'm just thinking the for every order of magnitude increase in data size, you're going to get an exponential increase in either resources required or time required to aggregate those queries.
Yeah, especially depending on your you know, how complex it is. But yeah, so that's interesting. They've got full text search, which historically has been a huge pain, like a regex type thing. But the good news is, with the advent of vector indexing, we can use AI embedding models to grossly decrease the cost. I've preached against using regex search for decades now at this point, like how inefficient it is to do a like asterisk, you know, and do all that stuff in memory. But with the advent of vector databases, you don't have to crawl through every record. You embed them once, so you've got your XYZ coordinates, and you're like, okay, this search is over here somewhere in this corner, and then you find your you just embed the search once and find your nearest neighbor and save money with semantic caching. It's brilliant. So,
I mean, it's constant evolution. It's constant paradigm shift. I mean, many years ago, I implemented a massive search engine using Lucene, which is a part of an Apache project, otherwise known as Solar. And it was exponentially faster at doing full text searches than MySQL was. And it did some really brilliant things with how it essentially keyed the data. I mean, it did a bunch of things under the hood. And this just sounds like a different evolution of the same flavor of thing. I mean, a database, a traditional database, is going to have much more, what's the right word I'm looking for? Stability, reliability, et cetera, than a keyed value store. Now, the difference, I'm guessing, with what is happening now, well, and don't forget, I mean, you're a cloud guy. I see you disagreeing. I was a pizza box guy, where when your server went down, your Memcache went down. Whereas now that doesn't happen the same way.
No, yeah. No, I mean, everything's designed to have multi-region failovers. Just it's got readers and writers, just like most data stores do. Or you can, you know, shard partition, or I mean, honestly, do both, of course. So I don't know if there's an advantage over uptime anymore with it. But it used to, like I said, it used to be very good at one specific thing, and they're expanding outside of that. So as long as they don't screw up the value key store being lightning fast, which I think would be tough to do, I think they'll do well. But I'm not sure how these other features are going to work. But I'm very interested to try it as a vector search.
Can you trust this? I mean, so this is read only, or are you going to be able to? Oh, that's not quite the right way of saying it, because everything you can write to it, of course. But is it going to be persistent? Is it reliable? Does it have?
That's an excellent question. You can use Redis as a persistent store, at least on AWS. You can back it up. You can spin up from a backup that way. So it's not usually a problem. There is by default, well, depending on the setup, I guess for AWS, ElastiCache by default will start evicting records if it starts filling up. So that's where you got a problem. It doesn't just say, oh no, I'm full. It starts evicting them. So
Is that like a least recently used sort of
yeah, you
algorithm
can
behind the scenes?
choose LRU. Yep, you got it. You can choose the setting on that to what you want it to be. But just most people by default say back, like, kick the last one because it's, you know, it's ephemeral data. It's a session or it's a, you know, cache for a web page or something. If for my uses, actually, that has been a concern, but I believe we can handle that easily by just making sure that we set the proper settings on it and monitor it. So if we see it getting anywhere near that threshold, do something about it, you know.
And
But
is that something you set within your AWS configuration? Say, I want the maximum index or size of this to be X, you know, gigabytes, whatever it happens to
they
be.
come in node sizes, basically instance sizes. So you could say this is how much, you know, space you're going to get for the most part, unless you do it serverless. Which, just fun fact for anybody thinking about doing serverless Redis on AWS or ElastiCache, they have a minimum billing size. Last I checked, at a minimum billing size of a gigabyte for memory. So if you're like, oh, I'm just going to play around with this thing with a couple megabytes, it's still going to bill you for a gigabyte, which, you know, it's like, okay, that's, come on. But I understand it kind of. I digress. Where are we going with that one? So
where are we going with any
you
of this?
could,
There's
I
no
think you could make it
destination.
work. You know, the thing I'm not seeing is it's a standout piece that like makes it stand out over other things. So I've done vector DBs on. You can do it in S3 now. You could do it. I did it in Mongo. I mean, basically, it's just some coordinates. Every major database seems to be jumping in on this thing. So there's not really like a moat around it. But with that said, if you're already using Redis and you want to get on the vector bandwagon, it might be nice to do that without having to do a bunch of other stuff. So I mean, yeah, I wouldn't mind benchmarking speeds against S3. I think because S3, it's another thing where it used to just be file storage. Now it's databases. It's a bit odd, but I wouldn't mind benchmarking it. If you didn't want to be platform specific, you might want to stick with ElastiCache over something like S3, because S3 will lock you into AWS's infrastructure.
So it seems like a lot of these tools are adding the same features or the same similar features, so they're becoming more alike. But what you said is, you know, essentially led me to believe that the challenge is going to be much more so now choosing the best tool, because they're becoming more and more similar all the time. Whereas had you already built something on ElastiCache, okay, it's easy to add a feature. But if you're looking at this from the outside saying we're starting something new, does it become more challenging to do that from both a speed, a scalability, a cost perspective, complexity, et cetera?
Well, honestly, I think it's probably a good thing, because you could choose your own weapons, you know, or, you know, your tools, I suppose, that they're all doing this, because and the magic's really in the embedding model is what people are going to find. Because if your embedding model sucks and it creates index, or, you know, vectors that are just nonsensical, you're dead in the water there, you know. So that's, I think, what the real magic is for where there could be some competitive advantage here. But from the consumer standpoint, I don't have a problem with it. You know, I'd love that if I jump on a, I'm not sure Postgres does this, but I think they do. But if I had a client, they showed up with Postgres, I could probably make it work with that, you know. So I can kind of choose. But the real magic's in the embedding model. You got a bad embedding model, you might as well be just rolling a dice and picking random records. If you got a good embedding model, you know, so how do you build the embedding model pipelines that train it? And you know that I'm actually working on a project that is training an embedding model right now, and I would love to talk about it, but not quite yet. But it's pretty amazing. Everybody, this LLM hype, I'm sick of. I'm on the embedding model hype train.
And vector databases.
Yeah, well, yeah. The embedding model creates the vector. Yeah, exactly. So, but yeah, I mean, you can build some really powerful stuff. I guess I can talk a little bit about something tangential. And there was, I just took a course recently where I got pretty deep in this, and there, I can't remember the exacts. The guy actually cites it, but there was this company that was awarded an award for drug discovery, basically. And so they were able to look at proteins and look at their previous performances, and instead of before they were lab testing everything and it would take forever, well, they had fairly sparse data, meaning they had a combination of proteins they had tested, and that would made up maybe like 1% of their data, and then there was 99% the other combinations of proteins and things, and it was able to create these drugs and tell them, hey, out of all the different combinations, instead of spending millions and millions of dollars testing all of them, here's the top 10. Just test the top 10 protein combinations. And is where I think the money's at.
I've read something very, very similar about creating new metal alloys, new combinations of metal that have different characteristics. And yes, the AIs can essentially roughly determine which ones are worth looking at based upon whatever your criteria of your resulting material, that the characteristics you're looking for.
Gotcha. Yep. And that is the type of stuff I want to work on, which transitions us nicely to a nice call to action. Is I am actively looking for people that want to collaborate on things like that, because I am getting deep in that technology. So I'm not just going to slap an LLM or chatbot on your website, though. We also can do that. It's not rocket science, but if you're interested in working on something like that, sure. But the stuff I'm really, really excited about is vectors and embeddings and how we can benefit mankind with that. Yeah.
Bring the data.
Off market data. We call it off market data. If you got some data, you've been collecting and you're like, what do I do with this? Give us a call. So
I've got ideas, but you've got customers we can't talk about yet.
Yeah. Yep. Well, we can execute on it. So with that said, Dom, thank you for joining me. You have a lovely evening wherever you are on the planet right now. And if you need to get a hold of us, I'm Matt with schematical.com, and happy to help you on your journey.
Happy Tuesday.